All right. So now we are going to talk about the review of how do we solve for the area of a triangle. Okay. And the beauty is that these formulas, these recipes, again, if you can remember back to fourth grade, you learned about different types of triangles, which those, what kind of triangle it is based on the angles within it and all that stuff. The beauty is that this formula, this recipe works for every triangle. So you don't have to say like, oh, well, that's a right triangle, so I have to do this, and that's a obtuse triangle, so I have to do this. Nope. One recipe, all the triangles. So that's the good news for you, is you don't have to get caught up on like, wait, but this triangle looks different, and then it's all good. So, but there are a couple things that are a little bit special about this one. So let's first just talk about how triangles are related to parallelograms, okay? So let's say, and I'll pick kind of a easy shape, like a right triangle. So there's a right triangle, right? So let's say we are trying to figure out the area of this triangle, and we know, do a different color, we know that the base of it, I don't know, let's say is 6 inches, and the height of it is 5 inches. Well, if I were to simply just multiply, right, if I think back to my parallelograms and I go, wait a minute, the area of a parallelogram is just base times height. So maybe I could do that. Well, remember, if I do base times how tall it is, I'm actually solving for a parallelogram. But that is good information for us, because let's look at, I just don't know what color to use. What would happen if I actually sort of shadow drew, like fake drew, that parallelogram that I would be solving for? Well, wait a minute. Do you see that that triangle and that triangle are the same? Again, I am not a computer, so they maybe not exactly the same because it's hand-drawn, but in theory, they are the same. So, all you have to remember is that two triangles, if you take any triangle and double it, right? Like say you put it on a photocopier and you make the exact same one and you cut them out, when you put them together, you will make a parallelogram. Now, what if we tried, just to drive this point home, what if we tried something that was not as friendly? And I will say this is going to be harder for me to draw as well. Well, that thing's funky looking, but if I were to copy it and cut it out and lay these two real long sides together, it would look something, again, not perfect, but I think it's pretty close. You would see that it would still be a parallelogram. Now, this one doesn't have right angles like a rectangle did, just like in parallelograms. You have parallelograms that the sets of parallel lines tilt, and then you have the ones that are straight up, which we call rectangles. Same thing here. A right triangle, two of them make a parallelogram, but so do any other triangles, any other types of triangles. You cut out two of them identical, you can piece them together and make a parallelogram. So, basically then, by multiplying 5 times 6, which is the base times the height, I'm getting the area of a parallelogram, which means I'm actually getting this whole area. And I don't want that whole area, I only want this triangle. Well, guess what? These two shapes are identical, which means once I have this total area of what this parallelogram would be, all I have to do is cut it. There's my eraser. All I would have to do, so let's just come over here to the side and say, okay, 5, right, there's my, well, that's my height. Doesn't really matter, but let's just for keeping it straightforward. Base, which is 6, times height, which is 5. That gives us 30 inches squared, but again, that's that whole blue area. So in order to only get this triangle, which is half of that, I'm going to take my 30 and divide it into 2 parts. And then that will tell me how much just this one is. If I cut it in half, I've been picking 15 a lot today. That was not on purpose. So by cutting it in half, we're literally saying, okay, 30 was this whole parallelogram. I only want the triangle, so I'm going to cut it in half and get rid of this part. Cut that number in half, and now I will have the area of just that triangle. So the formula for triangles is the area is 1/2 of the base times the height. Okay? And again, the beauty of this one, you see fractions and you go, you're just cutting a number in half, dividing it by 2. That's the same thing, right? So if you just solve the base times height first, then all you have to do is cut that number in half and there's your answer. So you don't have to necessarily worry about multiplying fractions by whole numbers and all that stuff. You don't have to worry about all that. Get this part first, as I smudge it, this part first and then cut it in half. Another way that some people write this formula or this recipe would be multiply your base times half. It says base times base. That's not what I meant to do. You multiply your base times your height, and then, if you remember, the fraction bar just means divide. So basically solve that first, and then divide by 2. And there's your answer. Okay? So if I were to do another example down here, let's say, and I'll switch colors so we don't get too, I don't know why I'm ignoring this side of the board. But let's say, and again, we got to be careful because this is where height is different than the length of the side. Those are different things. Height is just how tall is it. The length of the side would be you have to measure it. So if you have something that's not straight up and down, meaning as soon as you tilt it, it's now the height of it is different than how long is it, right? The height is from the bottom to the top, how tall is it? Whereas the length of it is like measure from here, from end to end. Okay, so down here, let's say the base, which is this bottom flat one, I don't know, let's do 10 centimeters. Okay, if this bottom one is 10 centimeters, remember, we want the height, which means we want how tall is it from the bottom to the top, basically. From this base to this base, how tall is that? How far away are these two parallel lines from each other? Okay, that's maybe the best way to say it, is how far are these two parallel lines away from each other. So in this case, let's say we do, I don't know, 4 centimeters. Then we can say, okay, so if I come over to the side here and I do, okay, my base is 10, and then I multiply that by, so you can use your dot or your X for this, it's not that big of a deal, times 4 centimeters, right? Then I get 40 centimeters squared. But remember, actually, I'll change this color. If you remember, that 40 centimeters squared is for the parallelogram, okay? And we don't want the whole parallelogram. We just want this triangle. So therefore, we're not done yet. We need to cut this in half or divide it by 2. So our real answer ends up being 20 centimeters squared. Okay? So for this one, you're taking what you know about parallelograms, and now you just need to find what half of that would be. So you have to it's kind of like you have to imagine a little bit. So imagine that you have 2 of the triangles, okay? And kind of think from a parallelogram stance first, which would give you that whole thing, and then you cut it in half. Remember, that just means half of that number, okay? Or, if you like to think about it this way, base times height, that gives you the parallelogram. Now, cut it in half, and it will give you just the triangle, okay? So hopefully that's kind of jogging your memory. Like I said, we did this the week before we went to break. We were working on memorizing these guys. The parallelogram is a real straightforward one to start because it's so closely related to rectangles. Triangles is kind of like, okay, now let's do one that's a little bit harder, but we're still using the parallelogram idea. Base times height. We're good with that. Now cut it in half to get the triangle, okay? And so the hardest part is kind of imagining what you're looking at so you can do the base times height and understand that that's a parallelogram. What I want to show you really quick too is I'm noticing on here is sometimes when you have just a triangle, like I drew in the parallelogram, that's why my line can go straight up to the top. But sometimes when you have like an obtuse or whatever triangle like this, it's kind of confusing because they'll label, let's say we label the bottom, I don't know, 14 feet or something. And then because you can't go straight up, like we don't want to do a line that goes up and then just kind of floats to nowhere, what they'll do is they'll bring this tip down and kind of show you here, you know, maybe that's 6 feet or something. They'll kind of find some way to show you, some notation to show you how tall. So basically you're picturing in your head, okay, if this line is parallel to this bottom line, how far apart are they? That's how tall a triangle would be. That's how you could figure out what the height means when you don't have a parallelogram, okay? So some are real easy and straightforward, and some they kind of come out. You just got to remember base to a line parallel that touches the very top tip of that triangle. So that is your height. Okay, base, bottom, height. How tall is it from that bottom line to the tip of that triangle right there? Okay, so hopefully that's clear. I know I talk a lot, and it's even harder when I don't have students to like interact with, though I do have your drawings. Email me questions if this something doesn't make sense, or or don't forget, you can go on YouTube, go on Google, go in Khan Academy now that you're in there, go anywhere and find area. If I'm not making sense to you or this is not making sense to you, ask me if you want. If you're not comfortable, because I know I'm not good at asking for help either. Just go to YouTube, area of triangles, and there's a million instructional videos, especially now because all the teachers are making all the videos. But even before then, I show you ones in class. There's all kinds of videos out there to help you and to see if someone who's had more time to like computer animate something might have made it a little more straightforward. But yeah, there's our area of triangles.